So we are recording now?
Now we will. Yes.
Okay. So reduce this picture. Thank you. Is the here is better, right? That way the camera won't see. Then it's your turn. Please come here because the camera can see you. Over there, I'm not sure. Are we recording right now? We can modify. So I know if you're here, they can see you.
This is good.
Yeah.
Well, first of all, I want to congratulate Bahr on this grant and all of you. It is hard to imagine that one grant involves so many folks throughout the college and different colleges. So welcome to our College of Science colleagues as well. This is truly remarkable. It's great to see the collaboration between so many folks throughout the university. Modeling and simulation is critically important. It is more and more so. I mean, I could have said it's more and more so 10 years ago. Today is incredibly important. I have a report that I was asked to comment on from the Department of Defense on digital modeling and what that means for the future of thinking about testing equipment in a digital environment. So we know that throughout the world that this is going to be an increasingly important topic. It's a critically important topic now already. As we're trying to support research in this college, it's really important to see you all here and engaged in this. Because as a dean, I can't support something that faculty doesn't want. Of course I can, but why would I? So knowing that there are so many of you throughout both colleges that are engaged in research, that are working hard to bring research-informed classrooms to the college, encourages me to continue to talk about research and how we support it here on this campus. I have been clear in my messaging to anybody who will listen to me, which is very few people, but to anybody who will listen to me, that we are not trying to emphasize research to get away from our mission of undergraduate teaching. It is to enhance our mission in undergraduate teaching. We cannot be a college of engineering. Dare I say, we could not be a college of science either. I don't want to speak for Dean Baskey, but since she's not here, I will. We cannot be either of those colleges without research. It just doesn't make any sense. And so regardless of what the campus does or thinks about research, we have no choice in this college but to support it in the best way that we can. So you'll see the way that we're supporting it now, pizza and water, right? We'll get better and we'll do more, I promise. But we have to make some initial steps, right? We have to get started in this journey. And it's grants like this, and it's these kinds of gatherings that will push us forward in our research endeavors. I'll mention it again, the research-informed classroom. That is where research and our undergraduate mission collide. I don't like to talk about research and teaching and even service as three different buckets. We don't like silos, and yet we build them all over the place. And we build them in our workloads, teaching, research, service. That dichotomy between teaching and research is false. It doesn't exist. Those two boundaries interplay with each other every single day. And you bring that to your students. And that's what differentiates us. That's what truly differentiates us from other Cal States and from community colleges, is the fact that we're doing research and we're bringing it to our students. So I want to encourage you to continue to do that. I know it's hard. I get that. It is easier not to do it than to do it. The fact that you're here doing it and continuing to try, just know that you have a college that is trying to back you as best we can. So, Ben, thank you for the opportunity to talk today. I can't, I tried to go on for 10 minutes.
Thank you.
And most good deans could go on for hours, right? And so we could keep talking, but I would just keep saying the same thing over and over again. Really about how much I appreciate you, how much I appreciate Ben bringing you all together, and how much I appreciate the work that you're about to embark on, knowing that it's difficult. Thanks.
Thank you. Well, thank you, Dean, and let me change this and get help from our technician to show you that. What are you seeing? People or?
Yeah.
Oh, sure. Okay, well, thank you and welcome coming here. And I appreciate each and every one of you and the dean for accepting to come and supporting our effort. I will explain a little bit more detail why we developed this proposal and why you have been invited here. It's very important. So just the title of our proposal that was funded is really iCARE, modeling and simulation. We worked with people to come up with that title, but basically we want to enhance the education for our graduate and undergraduate in terms of modeling and simulation, and provide opportunity for all of us for our research and advising our students. What is important, we have a grant about $1.1 million from Department of Education that needed to be matched, and the Ganpat and Manju endowment was part of the matching so that we can get this grant. And then it wasn't enough. We had to resort to our dean. And I'm very glad to have this dean. Otherwise, it would have not been possible. And I mean it seriously. So thank you, Dean, for supporting this without knowing, I guess. And I'm going to go and give you a little bit of a history of how it started. There is three pictures here showing simulating this simulator, which is for, let's say, testing vehicles, or it's being used for auto car industry for racing. So they get training on that. So we purchased that simulator by the fund that came to us from Department of Education. And we were setting it up and got the students involved. Obviously, their budget ended. And then we were very lucky to have Ganpat and Manju came along and supported and gave $1 million as a philanthropic donation to the College of Engineering so we can continue this effort. And the time that happened, as you can see over there from my student's picture, it was the COVID time. It just happened to be at that time. And nobody was allowed to come on campus. I was maybe one or two faculty was allowed from College of Engineering, and these three students are the only one. And I should have been here, open the door, do some testing prior, all the stuff that need to set up the equipment. And so we started from there. And then, so as you can see, old picture, beautiful building that is no longer there. It's an old picture. So we had a lot of students interested in working with me, but I wasn't ready to take anybody. I wasn't having a lab space. I didn't have any equipment. And it was COVID. I just didn't want to deal with them, but they would come. As you can see, some of them are there taking a senior design project, some from math department, some from computer science. They came with their advisor and joined my team working on it. Then we invited President Kohli to come and take a look at this system while nobody is here and run the system. As I said, then with the generous donation from Ganpat, we were able to get a better vehicle with more sensors to test our capabilities. And what it is, this vehicle is a test bed. So you can do all of your project with this in the area of your expertise. And that's one of the reasons why you all are here. I intentionally didn't pick the best people in the college. And the most important part of these faculty are they are good. They are here helping students all the time. They have that common goal with them. Some people could have been on this project, but I didn't choose them. I'm sorry. I wanted people who can work with each other and are friendly with each other. So make sure we are friends from now on. and not only you be friends with each other, collaborate, but also we want our students to learn that as well. Whatever I'm saying is in the proposal, by the way. I'm just going through my proposal as I'm talking. So now that, thank God we have a new dean. And as I mentioned, now we move from that copy room to a bigger room in 101, which is in this building. And it will be prepared for grand opening, possibly in fall, I believe, sometime like that. It's not perfectly cleaned up yet, but the students are there and doing work. Meantime, we are inviting people, or they have heard about this without much publicity that from my end going out yet, the word of mouth. So there are students, elementary and middle school coming in, and they wanted to test. And these students, they know Python, and we are teaching it over here. So they're amazing group of students coming in, and probably will be your future students. Then we were lucky in a sense that Bia from Department of Education happened to be here on a conference, a STEM networking or something. I happened to know that. I invited her to come visit our lab. And I think she was impressed with the diversity of the people and sincerity of the students. And at that time, she announced that there is this modeling and simulation grant for the whole CSU system. And that's what it was the conference about. Not just about that. So I picked up on that, and we started writing the grant that fits this autonomous system. I call it autonomous system because it encompasses every one of your expertise. It just you cannot do by yourself. Mechanical engineer, only they take care of shock absorber, brakes or something. We need traffic control, we need vision system, we need electric vehicle understanding of what it is. Each one of you have expertise, control, path planning, as I'm looking at this electric car, and the software part, and artificial intelligence, and cybersecurity of that. Okay, each one of those topics are needed for developing autonomous system. I call it autonomous because right now we are working with vehicle. Tomorrow maybe submarine, underwater, or UAV. Whatever we develop, it applies for everything, or even walking robots or something like that. It really all of them together. So that's why I brought these people who are expert in each area, and we can help each other to move this project forward. And now the next, what I am thinking to get a better vehicle where it has a shock absorber, it has a brake system, it has a reverse, and it's, by the way, it's electrical. And now we're gonna put all the sensors, whatever is needed. I'm gonna share all of these with you so you can input to me before I buy this one. And if we're gonna build it this year, test it, remotely control it, and also make it autonomous. I forgot to mention one thing here on this picture where I am having my iPhone there, and Ganpat, the dean, and everybody else is there. This vehicle was tested at that day, and it was running from India, Ganpat University. Their faculty were controlling the vehicle, and I was videotaping to show what we are doing to them. So that's how we did that. I forgot to mention, I apologize. Now, so we're gonna have enough money to buy some of this equipment. If you wanna build a fancier one, the budget is not allowed. I wanna mention the $1 million, half of it is gone for indirect costs. So we have about 600,000 for 3 years, every year about 200,000. And I'm gonna hire about 15 students to accommodate each one of you. And you know, the budget is almost disappeared when you hire students and equipment. And there is some for you as well.
That's true for me.
Now, as I told Dean that this is the best group of faculty because the budget is not enough to make you really happy, but you're dedicated and you're collegial. And so.
This is the first time you're hearing.
We all work on the same type of a topic. And then, as you mentioned, Dean, we are in silos and everybody wants, and they should develop their expertise, right? But here is a chance for us to collaborate on whatever we are doing and not only learn from each other, but teach each other and teach our students. So since we love to teach, and you mentioned teaching is important, we actually are developing online course modules that, for example, when a faculty teaches a certain course, they will develop these online modules that they can use in their courses, but it will be available in the College of Engineering website for a student from other, let's say, mechanical engineering wants to learn about electrical vehicles, what goes in there. They can listen to the lecture enough, be exposed to that type of a topic. So In fact, if we do a good job on this type of thing that I am envisioning, in future, we can develop certificates in certain area for this type of a project. But that will take some time. As you know, going through certification, it's difficult. But we can have what the university has done, digital badging. And I have invited the person who is going to tell us in a few minutes what that is going to be. So we're going to develop these online modules, and then we have to meet the guideline of federal government, which means it should be ADA compliance. So like the blind person can see or hear. I don't know what they are. I'm going to have a workshop for you with the cafe, the director of Cafe Victoria is going to come and give us the presentation, what to watch out for. So the course that is going to be published, we don't be sued for trying to share something. We're just going to make sure we meet those guidelines. And we're going to recognize in our courses, Department of Education and Ganpat in the beginning for, for that course, whatever you are developing. So our goal is, whatever I'm saying is in the proposal. Certificate, long-term, digital badging, short-term. And since you said we are going to advise our student and mentor them, and both graduate and undergraduate to be successful. And that's the goal of all of these faculty here. They really want to produce the best students, and they do take their time to help them with their project. I have seen each one of you, and they love to work with the students and each other. Important, each other is important. And then you saw the picture I had. There was a diverse group of students. I want to develop that, and not necessarily, you already are doing that. It's going to be diverse group of people. Anybody comes, they are interested in autonomous, it's going to be welcome. But faculty doesn't have enough time to, let's say, advise 20 students from other departments. They barely have enough time for our own students. But so here is the beauty of this proposal. We're going to hire those students. They're going to be sitting in the lab over here, room 101, from let's say 9 to 5, we schedule them to come and sit, and maybe it's you're a student or another person a student, because they're paid. So they will be working 10 hours a week for the lab under your project. But if somebody comes and they're from electrical engineering and mechanical has a question, they can be a mentor themselves. So we are training our students to become a mentor as well. Those 3 students that you saw right now and the previous students, they were so good helping other students, and we built that culture in this facility that I have right now. And then when I started the proposal, I could have selected 1 or 2 faculty, that was enough. But I wanted as diversified faculty as possible. And I know everybody is working more or less in the similar area. Okay, let's put them on this system and we can work together and help each other. As part of this effort that we are doing, I don't know my time, but anyway, as part of this effort that we are doing, we want the students to be technical leader, but they gotta be working in a teamwork, and not only with friends here, but we wanna reach out to, I said, global environment, because we have partners in India, Ganpat University, and it is really important to be able to do that globally, because students, when they get the job, they have to work with people from all over the world. I have 2 sons, they are working in the companies, 2 different companies, and they are talking to Germany, India, Japan, and odd hours, they wake up and do it on the Zoom and all that. It's the nature of the work right now. And if we get that chance to develop and tell our students, hey, you have to be here 7 o'clock, it's preparing them for that. And as I said, then one thing we promise, whatever I said here is in the proposal, and 50 pages, condensed version of it is we're going to publish our results, okay? And I want all of us to work together, maybe 3 of you or so forth, or 15 of us on the paper is okay. It really help us to publish and present this. And then we would like to possibly develop a student club for autonomous system or car or vehicle. For now, I said the autonomous car. But remember, we are not just the car. Whatever you are developing applies submarine, UAV, walking robot, and firefighting robots, you name it. It applies to every one of those. And please correct me if I said I picked you guys that were the best. If I'm wrong, correct.
Right, right. Absolutely right.
Oh, the first time I was right. And then here is Victoria. We'll decide probably, I don't know what day, but I think it's 2 hours would be good to have workshop, just so that you don't be sued, we don't be sued for developing your online modules. And so I have given you the list of courses already. Each person will have 1 course at least to be developed. And the first 6 are the one that are going to be supported this year. That is what was proposed. But if you don't want to do it, we can modify it and put you to the next year or so forth. And just to let you know, you get $7,000 for all that work that you're going to be doing for 3 years. Only one time you get paid. Now, the goal of my students our students now is this chart. So we're going to hire a bunch of them, 15 of them if possible this year. You see the undergrad cohort, the same thing is for master. Combination, 15 students. If you like to support your master student, you will hire them. $20 per hour, 10 hours a week. Not much, the budget wasn't enough. But this, let's just stick to undergraduate because Dean said those are important. And so they come this semester, and next semester they graduate. So that's why I wrote down semester 1, semester 2. But there are 15, and there may be 30 students want to be involved. So the juniors one come along and tag along with these other students. They learn, and these people who have experience now, they become senior and they get paid at that year when they are senior. Then the next generation of juniors tag along. It could be freshmen want to come in, we don't discriminate. We accept whoever wants to work with us. And it's going to continue like that till 3 years. And after that, I'm hoping within these 3 years, we write more proposal and more research paper and get recognition in CSU. I believe we will be the first one, if we are not already the first one in CSU system to have this and develop a trust area for our research, get recognition. It would help all of you. And I think we'll enjoy disseminating our knowledge furthermore. I am done, and I don't know how I did with time.
On time, yes.
Wow, unbelievable.
4 minutes, yeah.
Thank you very much. We'll ask questions later because of that time restriction. I think Priyatham,
Yes.
close enough.
While he's getting set up, let me just mention two things quickly.
Yeah.
I did not necessarily mention graduate programs. I don't see how we have robust research happening unless we're building graduate programs alongside of that. So that was an unspoken part of
Is
the
there a way,
whole thing.
is that a website?
But again, a graduate program that enhances our undergraduate mission, doesn't replace it, doesn't dilute us, but enhances that undergraduate mission. The other thing I'll mention is that we are talking to some donors now about a
You know how to
center.
do it?
It would be likely called the Center for Exploration and maybe some other junk. But what you saw presented earlier has that exploration part of it. And so there are other parts of the college that can help keep this going and infuse some funding as we build this. So don't view $7,000 as the end of the rainbow. To me, it's just the beginning of what's possible.
Okay. On behalf of faculty.
Okay. Hello, everyone. So thank you, Dr. Bahr, for this opportunity. So I'm Priyatham. So I'm working with the Innovation Incubator in seeing the digital credentials and digital badging part of it. So we have seen how students will be based in cohorts. They'll be able to finish our program in modules. So what next? So what are the students really gaining after they finish? So we are going to provide them with digital badges so that the students can get a sense of achievement on what they have done. And also the most important part is share their accomplishment with others, especially with social media and importantly, LinkedIn. So we want students to be able to share what they have learned as part of a digital badge with the world. So we're going to do that with a few steps. So we have decided on what badge are we going to award. So we're going to award a program badge. So since this is almost like a program, we're going to award a program badge that has the name and the issuer that is going to issue it, which is the College of Engineering, the program, which is the iCARE program. So this is the program badge that the students will be getting after they finish all the modules. And when we look at what does the badge contain, we have two important things. We have the description and the earning criteria. So these are the things that I would need your help with, is fixing on the description and the earning criteria. Description is what the program is all about, which is not really hard, which is already done. The real part is earning criteria. So what is the student really doing in order to get the badge? So this criteria is something that you all will define. So after all your modules have been finished, you and Dr. Bahr, of course, will provide me and the office with what is the student really doing in order to earn the badge. So this is what we will be putting in the badge as well. So this page that we're seeing is exactly what the student will be seeing, and the employers who are looking at the badge shared by the student will be seeing as well. So we need as much information as possible so that the employer can understand, okay, this is what the student has really done in this program to get this badge, so that they can identify the skills that the student really acquired from doing such a thing. And so this is almost it. And how do we award the badge? So we fixed on what badge are we going to give the students. We decided on what the criteria needs to be. So how are we going to do it? So once all the students have been enrolled in however might be the medium, we would need a CSV file of all the participant learners. So we would need the email addresses, the first name and the last name of the student in order to just award the badge in bulk to all the students once the program is done. And as the program repeats, we can do the same as well for any number of cohorts that Dr. Bahr mentioned. So this is the format that we would be going for with the digital badging. So it's almost all fixed in. So once you all are ready with the earning criteria and the students who are entitled to the badge, we can make sure that the badge is awarded to all the students. And that's it for my presentation today. And if you want to know more, you can always ask me right here. So yes, I'll hand it over to Dr. Bahr.
Thank you very much.
Thank you.
I guess if you want to get a coffee or something or water, it's maybe the time. Otherwise, we're gonna start hearing from the faculty 5 minutes or 4 minutes. So let me go, not there.
The other one?
I'm gonna go. Let me go.
Okay, you want the
No,
presentation or this?
I have to go to different file. Sorry. Reduce. What is this? I'm gonna share a faculty presentation. It's in here. Where's that guy? I don't. Ah. Oh, no. Let me see. Oh, it was already there.
Close it,
Yeah, yeah. it
close it
was.
and open another one.
I already saved all of that in the,
Individual.
no, all of them were booked under the same thing.
Which one is largest one?
We put everything in one
First one is
file.
maybe.
I did it.
It's first one.
Bio, maybe
So profile-
bio. Oh,
profile-
faculty bio. No, it's here.
Yeah, that's the right one.
That's
Yeah,
the
this
one. So go ahead, increase that. Yeah.
That's one. Let me see.
Could you put in presentation mode? It doesn't go.
Is in the president or right there? It's
Huh?
in-
Oh, it
It's
is.
already-
Okay,
it's
okay,
already,
okay,
yeah.
okay.
So you just need to move it.
All right, what is this? Okay, we are in presentation.
Yeah, but it's down.
Okay.
Yeah.
All right, you all know me, my presentation, you heard me, thank you. Robots, I do, what was that? Biologic inspired robotics, autonomous system, and person-centered design for haptic devices. That's another interest of mine. Now, I don't want to take too much of time. Next presenter. How come it doesn't show? What happened?
I need to ask.
Special.
How come it doesn't show?
Slideshow. It's in slideshow mode. Begin.
That's
Copy by-
that's the one.
that's
Yeah,
the one.
yes.
Or is it this
No,
one?
no, that one. That one. That one. Click on that,
Okay.
share, and now that be,
See,
no,
it's not
let's see.
changing, it's the other one.
It's
It's
not
not,
changing.
no, it's that one because it has everybody here.
Why no, but so was the other one.
No, it didn't. Okay, if
See?
it has. No, it's only me. Okay, maybe
see.
that's the one. Okay. Oh, yeah.
See?
Yep.
That
Thank
was.
you, thank you. Okay, your turn.
Okay.
All right, please go ahead.
Oh, okay, yeah. So I think I should start talking because we are 5 minutes late. Okay, so that's me. Okay, so
Everybody gets
what I
3
do,
minutes.
power system. When I specialize in power systems, so power systems are very big. So certainly we need modeling and simulation. So we do simulation and modeling all the time. So I do wind and solar energy, electric vehicle and energy storage, and smart grid technologies. So just to tell you a little bit of story that I started wind power research over 20 years ago. And at that time, there's no confidence in wind power because it was expensive. People say that nobody's going to use it. But I said, over time it's going to develop. And time proved that I was right. So I guess I can move on to do fortune telling, then maybe make more money than doing research. But anyway, so that was a little bit of story. So the simulation that you see on the left-hand side, the Simulink file is the most recent research that we did. It's a multifunctional energy storage system to support solar system and distribution system. The energy storage system is a real one from Southern California Edison, and we just published the work a few months ago. So the one below it is my prime recently. That is prototype of a 18-wheeler Class 8 vehicle. And I just proofread the publication the last time this morning. That's why, and I almost forgot about this meeting, but anyway, I spent a little bit. So I could get here on time. So that's what I'm doing.
Thank you. And next.
Almost.
Next.
Hi, my name is Zekeriya Aliyazicioglu, everybody calls me Zeki. I'm happy to be here and share a little bit about myself and my work in the field of electrical and computer engineering. I'm serving in the electrical and computer engineering department here. I'm mainly focusing in signal processing and communication area and image processing also. Primary, one of the goals is image processing and computer vision. Data is raw data, how we can make useful information from the raw data, how we can analyze this one. So we use some kind of algorithm, that's why I'm working on that one. Second is, another one is area is on autonomous vehicle interest about the sensor vision, using different sensors, the collected data, make some decision from the data, which is a kind of signal processing. And also I work on for a while about direction of arriving estimation area, how we can use the data to make final decision about how we located certain location with using image processing, and also using the area antenna design tools in the same area. I work on a little bit about machine learning for a while. My machine learning mainly focus on intrusion detection area, and basically collect the data, make the final decision about how this data will give an intelligent idea where is the road, some mistake, or how we can fix the mistake right there. Again, I would love to talk to you guys if you have anything interesting area collaboration. Feel free to just talk today another time too also.
Thank you very much. Oh. How does it go next? Yeah.
Hi, everyone. I'm Saeed Monemi and ECE faculty member. I've been here since 2001. And my main area of research is basically on power system, modeling of the grid, the power grid, and electric motors. I put some photos in there, so perhaps you can look at some of the work that we did in the lab. We have a physical location, 9-139. The lab initiative started in 2009, and then we received a grant from Department of Energy, which enabled us to purchase the equipment that I have in the bottom on the right side, which is a real-time digital simulation modeling equipment that Edison is using that currently, several of those. They cost about $250,000 each. And then on the left side of that, we have 3 racks of Schweitzer protection relay. So what we really do is we take the real model of the power grid based on the IEEE standards. We build it very, very similar to what Edison and San Diego Gas and Electric builds. And then we tested for different scenarios, for instance, fault scenarios or protected devices that are very expensive, such as large transformers and so on. So students get to do this. Currently, I have about 15 to 16 students, and that's averages about each year, 15 to 16, and about 2-3 graduate students, and that they work on systems like that. Another project we do in there, we actually build a testbed prototype model of the real world like a smart grid using 3D printer and other microcontroller technologies and so forth to do different things like load analysis, load shading, fault analysis. And then that's the picture in the middle. The picture on the top is other stuff that we do on the side as well too, such as building a solar panel, and that one on the very top is retractable solar panel that actually works, and it produces about 40 watts, for the students just to do some work in the lab. And then on the left side, at one time we built an electric vehicle. Students did a lot of work on the electronics part of it and put in an electric motor in there just to test it out. It ran for 20 minutes on one battery, and it changed to other battery for another 20 minutes. So we were able to run this around the campus for about 40 minutes. So I'll just sum them up.
Thank you very much. Easy.
Hello, hi. So my name is Yizhe Chang. I'm a mechanical engineering assistant professor, and my major research is in robotics and human-robot interaction. I think nowadays, actually, robots are not just like something for industry use. They actually goes into the daily life of our education, our service. So one of my research actually is develop a so-called intelligent indoor passenger vehicle. Someone says wheelchair, but that's right, but refrain from it. And that it can navigate through human-rich environment, working with students to implement this concept. And the other one is actually a SPICE-funded project for our classroom innovation. We wanted to innovate our undergrad research with more automation and robotics things in combination with sensor and this type of traditional research. So yeah, so that's what I'm doing. And the last one was a fun research that help children to remove, help families to remove those toys on the ground. And you should know that how to do that. It's just a fun project. Yes, so I'm very glad that I can join this project, and I will mostly work on the course called robot motion planning, and we integrate some of the new things and with the old things. Yeah. Thank you.
Thank you.
How are you guys doing? I'm Scott Boskovic. If you don't know me, I teach electromechanical. So I'm seeing a trend that we all have some like robotics on our slide, which is really cool. So I've been doing robots for quite a long time. The top two pictures are a robot that I actually built with a couple of buddies of mine before I was even full-time in this university. I've been doing robots for a long time, mostly autonomous vehicles. And in the bottom picture is actually a class that I teach autonomous vehicles, where I'm taking all these concepts and actually putting them into the classroom at an undergraduate level, trying to take the charge of what the dean's been talking about. Then there's also a robot that they're building. They actually build robots also. So we go into all those details, all the electronics and mechanics and all that. My area of focus is really how do, not just one vehicle, but how do multiple vehicles work simultaneously with one another in a cooperative and collaborative manner? That's it's kind of taken from the theme of intelligent transportation systems, which is a big application of cooperative and collaborative autonomy, which is where my dissertation has been. Now I'm taking that and I'm actually then taking and developing FPGA processing architectures above and beyond just a traditional processor, so that we can actually develop better levels of autonomy that we don't otherwise get, and do it faster in a more efficient manner. So how do we blend all that in and then combine all that into sensor fusion with computer vision? Right, all of this is when we talk about autonomous vehicles, sensors are key and important. Blending that data is very difficult. So doing that in conjunction with advanced autonomy in the FPGA becomes more prevalent than trying to do that in the processor, because of throughput efficiency. But the applications of all this obviously is, like I said, intelligent transportation systems, robots on wheels. When we look at all of this in conjunction, we realize it's actually complex and chaotic or complex adaptive systems. And the bigger problem we have is most of the approaches that we deal with right now are ad hoc in the algorithms. How do we provide closure? How do we know that when we design that algorithm up front, that we know it's going to do exactly what we do? And moreover, what happens when we do that, when we have 100 of these vehicles simultaneously, like we might have on the road? How do we ensure closure? So my most recent stuff is actually applying complex systems analysis, adaptive complex systems into a chaotic application, and understanding the dynamics associated with those systems, because the perturbations of the initial conditions become apparent. That's about it.
Hi, everyone. My name is Reza Baghaei. I'm an associate professor in the mechanical engineering department. My research area of expertise is not robotics, so it's totally different. It's thermal fluid science and renewable energy, and developing new technologies that help the future of a power grid that is 100% relying on renewable power. So decarbonization, devices that can generate process heat from excess power or extra power in the grid and store them in an expensive system is the core of what I do. I've worked on several projects with US Bureau of Reclamation and Southern California Gas Company. And also, so on the figures, you'll see some of our research on the repurposed desalination salts for thermal storage. And also on the bottom left, you see a water desalination system that we developed in the lab using this from industry. The reason I'm very interested about what we do here is my interest in simulation and thermal management. So if you own a electric car, or if you have seen electric cars, you see that they have a new problem now. They have to keep the battery in a certain temperature range, and in very hot condition or in very cold condition, that would be a challenging situation, and that applies to all but something. And that's what the subject of my course is.
Okay, I'm Tamer Omar. I'm a faculty at the Electrical and Computer Engineering Department. My PhD is from Iowa State University. And I thought like having a video can express some of what I'm doing. So you can just like play the video on the bottom to the right.
This one.
To the right, yeah.
That's
the
my.
last one to the right.
Or is
Just click.
Yeah. So this is showing mainly, I would like first to thank Dr. Bahr for getting me into this from the very beginning of starting this autonomous lab. And you can see here, this is some of what we started doing on the lab mainly. So you can see here, this is the car or the vehicle that Dr. Bahr was showing. And you can see here, they were doing some testing that's mainly on the baseball field here, and our students here is like mainly on the lab using the simulator that Dr. Bahr was showing. As you can see, like the car is moving over there. We're controlling it. Here we are not doing autonomous. We are doing what we call it remote pilotless. So the student is controlling the car. They are seeing the environment from outside. They can kind of like mainly go on and drive it. So you can see we're driving over like mainly as far as the environment. That was the first version, or the first what we call it in cars, like the first model that we create out of our car. Our new models now have, like the new model that we have now is more advanced. We can have some autonomous, so we have two modes now in the car. We have what we call it the remote pilotless mode. We can use the We can use this simulator. We can use a keyboard. We can use a remote kind of like a joystick to control the car. Those are three methods that we use. But also we have another what we call it the autonomous mode. So this is the remote pilotless versus the autonomous. And within the autonomous, we start like mainly working with trying to do lane detections. We are trying to do what we call it adaptive cruise control. We are doing like a lot of those autonomous things. So we can stop this one. That's just like one of them. The other one is more into drones. So that's mainly trying to detect and detect drones. So here you can see that we are using what we call it software-defined radios. This is the other area that I'm working in terms of communications, but that's my background. And here we are mainly trying to detect drones and trying to, like, if they are hostile drones or something like that, we're trying to bring them down.
It doesn't let me.
So
It's autonomous.
let me do it. That one.
I did. Come on. Anyway, that's okay.
So that's mainly for the second thing. I also like do a lot of things related to cybersecurity. So in this project, for example, I was doing detection of intrusion detection. This one I was collaborating actually with Dr. Reza on that one. We created an application for the desalination system. So there are like mainly some of what I'm doing. That's it.
Thank you. It's you. Anywhere you want, you can be there. But speak loud, so.
Here's Farbod, Khoshnoud. My area is mechatronics. And also I've done some work on the building UAVs, solar powered UAVs. Some of the grants that I had was from outside of the US, like the UK, most of it, but I'm still trying to apply more and more, but then I'm trying to integrate race-based quantum communication with robotics these days, but still work on the other areas like robotics, which I teach mechatronics, robotics, dynamic, static, usually electronic systems. That's all.
Okay, thank you.
Hello everyone, I'm Javad and I'm awed by seeing all the great research you are all doing. So I'm with the Industrial and Manufacturing Department. We also have a systems engineering program that I teach in. I have worked on mostly mathematical optimization of different systems. So industrial engineering, system engineering are sort of between engineering and business. So we tend to go a little higher level looking at the systems you think in a broader scale, like Scott was mentioning. So a lot of research I've done has been flight and maintenance planning, making mathematical optimization models for those, prognostics, integrating or making systems that integrate all the outputs of signal processing. So outputs of signal processing, not signal processing itself. How do you integrate all of those and all of those efforts? And another area is vehicle routing problem, which is very relevant to this project. When you have a bunch of these autonomous vehicles, algorithms that optimize the routing of those, and for this project specifically, I'm very interested in training students to become generalists and systems engineers who can integrate knowledge of other expertise, bring it into one system using model-based system engineering and other stuff. I've been fortunate to work with other colleagues before, like Dr. Baghaei here. I did a small shared project with him, and Dr. Shafai from mechanical also that you see in that picture, she's sitting. We have developed or made an electromechanical system for a private company. Wasn't allowed to show its pictures, but it's basically close to mass production in a year. That's been a very successful project. Thanks, everybody. I'm very
Thank you.
grateful for being part of this.
Thank you. Priscilla, not here, but I would like,
It's not showing.
huh?
It's not showing.
Jeez. Next slide.
Next.
Next slide.
Oh, how come it didn't show? Oh,
Yeah, this is it.
all right. Anyway, we need to have some AI work in our system, decision making, where to go, and augmented reality and so forth. But for sure, all the sensors that comes together, everything, we need a decision making. I think all of you or some of you are working on some of that, but that's the main contribution I think I seek from her to help us. If she was here, she would have explained more, but I'm going to move on.
Hi, everybody. My name is Salomon Oldak. I'm with Electrical and Computer Engineering, and during my free time, I'm the faculty director of graduate studies for the university. I also work in another grant, which is the Grad grant, that takes a good part of my time. In terms of research, my focus is on control systems. I like control systems because it fits into any area of engineering, multidisciplinary. Once I have a model, I can work with a model without really thinking of what part of engineering it is. Within control systems, there are several areas, and I focus on a robust control, which basically means that you have a system with an uncertainty. There are a lot of things that you don't know about the system, and you want to make it work precisely. So you use feedback in order to make it work precisely. I try to do that in a quantitative way, which means that there is a measure of how well you're achieving your objectives. There is also an optimality criteria to your design. To a certain degree, I can also do time varying design and also design for some classes of non-linear systems. I think that's it.
All right, everybody, so glad to be here and also feel very relaxed, especially in the meeting full of mainly friends, so I can talk freely. Okay, so thank you, Dr. Bahr, for setting up such a great meeting.
Thank you.
And, my name is Yunsheng. I'm from civil engineering, and I have some overlap with Scott and some other faculty, especially in terms of intelligent transportation system. And my main expertise is traffic safety. So, Dr. Bahr, I have heard lots of exciting things, about the computer vision, about the communication, cybersecurity, robotics. But all those things fundamentally get brought down to what? To the safety. Yeah, safety, because if it's not safe, we cannot, get it implemented in the real world. So, even though I clearly demonstrate my friendly side to all of us here, but then we talk about safety. Everything is serious, right? There is no friend or you lady first, something like that. So everything is just have to be security oriented. And also that's why, from the picture you can see, I just feel a little bit embarrassed because all the others you show very exciting, inspiring, photos. But for me, for safety, it's very difficult to find some vision-friendly or vision-inspiring research, right? A lot of the research is like accidents, fatalities, injuries is very stressful. So I try to find select those two photos to show actually, safety, can also be rewarding, can also be, free, like talking to the students in the workshops and get rewarded by some, get awarded by NHTSA, National Transportation Safety Administration. So I'm so glad to be part of this exciting team and look forward to working with all of you guys. Thank you.
Thank you.
Hello, everyone. My name is Yunsheng Wang. I'm an assistant professor from Computer Science Department. Thanks, Dr. Bahr, to invite me to join this wonderful team for all the experts in College of Engineering. So my research right now, I'm focused on the connected and autonomous vehicle from two parts. One is more focused on the vehicle communication, networking, then also for the autonomous driving. And last semester, I teach a new graduate course for connected and autonomous vehicle, and found that we still lack of different resources. So that's why this is a good opportunity that we can bring all the simulation, all the test bed for our students to use. So right now I'm lead a lab for artificial intelligence of things, and we have several undergraduates and graduate students working from the small, like the second level is a donkey car, small vehicle, to the two-wheel robots and the four-wheel robots, and we bring it from scratch and we add different LiDAR camera system. And before joining Cal Poly, I'm an associate professor from Kettering University, a former General Motors Institute. So the bottom the picture is the vehicle we developed and the participants in the SAE International's Auto Drive competition, which is a student competition. So that's why I see Dr. Bahr mentioned we want to establish student club. So I'm very glad that I can involve. So we are in a team from different departments, different supervisor from mechanical engineering, electrical engineering, computer science, for students, faculty mentor for the students, and we develop, try to develop level 4 autonomous vehicle on the Chevy boards with LiDAR from Velodyne, and the radar from Continental, and also the computer system from Intel. So right now, that is still going on. I hope that I can work with all other faculty here. Together, we can, in the future, we could also participate in this type of competition. Thank you.
Thank you. Okay, our last is the best, I guess. Talking stuff that I don't understand, quantum. So please, Dr. K1 Navi is in computer science. And please go ahead, tell about yourself, expertise. And if you don't tell, I tell. Go ahead.
My name is Kevin. I'm very glad to be here. I hope you will use. I got a Bachelor of Science of Hardware, Computer Hardware, Master of Science of Electrical Engineering from Sharif University, and PhD of Computer Science from Paris 11. And I work in 3 different areas. I'm just a lecturer in computer science department. I work in 3 different areas. The first one is the research, all of New York researchers. And it's a very good thing. You can publish a lot of papers, your H index will be increased and your citation as well. And you may even be selected as a top scientist in all over the world. I don't know if it will result in money or not, but you may have some patents and you may sell your patents. But all of us, we do know that making a patent, it takes a lot of time. And at that time, maybe your patent won't be useful. The second area is teaching. I adore teaching. I love my job. when I was young, I was always thinking, if I were a handsome boy, maybe I would be, sure, I should have been a actor. Because I always thought that I need to attract the attention of people. But that was not true. Why a nodding hand like this encouraged me in something like that will disappoint me. It's the enthusiasm, all of us, of making people understand. It's a challenge. I love this job. But the other reason that I really love this job is that when you're teaching, nobody asks you to sell your thing. We just teach and we are evaluating. The students evaluate us and we evaluate the students, and that's all. That's a great thing. The last and the most part of my job is to design in order to sell. That's what I've done long before for my autonomous car, and I was not able to sell. Why? Because when rain is involved, everything will be gone with rain. Rain is extremely important, even more important than snow. And the other thing is security. If somebody wants to steal your car, what's going to happen? If they wanna make it misconducted, what will happen? If you attack a human person, a living object, I don't know, anything, it will make a lot of serious problem. That's it. The last part, I think it's the most important part, because it is directly guided and resulted in money. I don't know it is important or not, but all of you, you're scientists, and I'm sure that you've got something like Google Scholar ranking. My Google Scholar ranking in cryptography and security right now is the first in all over the world. Fuzzy systems second, and computer arithmetic is fourth. Nanotechnology is eighth. My real expertise is quantum computing, but I don't know, every day I'm losing my ranking. Right now is 120. Recently, I've been selected as a top 2% scientist in all over the world by Stanford University ranking. I would be more than happy if you help me in order to have a joint venture, work together. Thank you very much.
Thank you. I'm glad to have all of you here. I suppose you all understood the theme, right? We all contribute differently to the same project and so forth. Oh, yeah, Alan, you didn't say.
Oh,
You were. Oh, I should
I've got it
mention.
showing to speak longer than Mr. Kivan.
No, I'm sorry.
not sure if I
The
can.
co-PI is Alan.
So I want to thank the